field of medicine and pharmaceutical science. So I hope I can learn these skills.
Excellent. Great to have you. Hanan Zogaid. Hanan Zogaid.
Yes, Professor. Hello, everyone.
Hi. Please speak louder.
Okay. I am Hanan Zukair. I have bachelor's degree in electrical and computer engineering. My specialty is telecommunication. And now I am doing a master of engineering degree in electrical and computer engineering. My specialty is artificial intelligence and robotics. This is my second semester actually. I took applied machine learning course and I'm learning Python. So that's why I participate in this class.
Excellent. Thank you. Janhavi Sabnis. Janhavi, I can't hear you. Giano Liu, while we wait for Janhavi to fix his speaker maybe. Giano Liu.
Hi. Hi, Professor.
Hi, Gian, go ahead.
Okay, hi, everyone. So I'm Jian Liu, and I got my bachelor's degree in electrical engineering and automation. And now I'm majoring in electrical and computer engineering in Ottawa right now. So I'm new in this area. I'm in the data science and machine learning, but I think it is quite essential on the new stuff for me to learn and by using Python. So I take this course.
Do you have a favorite context that you want to use machine learning in?
No, I'm new in this area.
Okay. Janhavi, are you ready to introduce yourself? Sorry, I can't hear you yet. Jinping? Jinping Ma. Mahsa?
Hello, Professor.
Hi.
My name is Mahsa, and I am going to my third year as a PhD student in DTI program. My background is I studied industrial engineering for my bachelor, then MBA for my master, and now I am in DTI. And the concept that I'm going to work as my thesis is about the supply chain management and the buyer-supplier relationship, and I want to apply the machine learning technology in predicting how the best suppliers can be selected among the other suppliers in terms of sustainability and other aspects. So I've selected this course as my optional course to learn better this technology and be able to work with it for my thesis.
First question I would ask is, what is the definition of best? But we'll talk about it later. Thank you very much. I have a test case today in supply chain, so you would be interested.
Well, thank you.
Noreen? Noreen Hussain?
Yes, Professor, I think I introduced myself.
Sorry, yes, you did. Sorry. The names are, I'm going by the participants panel and all is getting mixed up, forgive me. Neil?
Yes, hello, my name is Neil Traris. I graduated a few years ago from Carleton in biomechanical engineering. Now I'm working full-time as a systems engineer here in Ottawa, and I'm in my second semester of mechanical engineering masters at U Ottawa. I don't have I didn't have an explicit application of this course I was going in with, but it's always been a field I've been interested in, and I'm hoping to get some hands-on learning here. So I'm excited for it.
Doesn't matter if you had a genie right now and you had that ideal context that you would have loved to use machine learning, what would it be?
I guess something in the biomedical sciences.
Okay.
Yes, something generally like that.
Okay. We are going to be focusing more on the unstructured data, but all the techniques that we learn are applicable in transaction data as well. So in the biomechanical field, if there is anything that you can think of that comes as an unstructured text,
Okay.
could be something that you can aim at for your final, if you could arrive at a consensus with your fellow group members. Good to have you. Osama Abu Safiya. Osama?
He said he has a problem with his mic.
Okay, Paramprit Singh.
Yeah, hello everyone. I'm pursuing electrical and computer engineering and currently into the third term. So I have worked for 5 years in IT industry as an automation engineer before starting my graduation in fall 20. And I have mostly worked with Java. I'm quite new to Python as well as data science. So this makes me excited for this course. And I would love to explore applications of data science and ML.
Okay, excellent. Java was when one of the first job I got in Canada about I think 22 years ago was as a Java programmer. I was a Sun certified Java programmer.
That's great.
So you can do object-oriented programming as well in Python, and so the knowledge is absolutely useful. Good to have you.
Agreed. Yeah. Thank you.
Phoebe, thank you very much. Phoebe.
Hi. Hello.
Hi.
I'm Phoebe, and this is my second semester. My major in Ottawa is MDTI, and my background is education and mental health counseling. And I graduated from Texas A&M University in the United States. And now I live in Los Angeles, and I'm ready to move to Canada in the end of May. So it's going to be soon.
Okay. Excellent. Great to have you. Maybe some areas in mental health that we use natural language processing could be an interest area to work on your capstone. Raghu, I think already introduced. Tarek already. Tim Leo.
Hi, Professor.
Hi.
So I'm Tim, and I'm doing my master's degree here in Ottawa, majoring in mechanical engineering. And for my bachelor's, I did also mechanical engineering in University of Victoria in BC. And during my bachelor's, during time for undergrad, I did some of C and some of MATLAB, and for the master, I took the data science course on the fourth semester, which used R as a programming language, but still I'm new to Python and kind of like want to practice it.
Great. It is a polyglot concept. All these programs can call each other. So R, Python, Java, whichever library you'd be interested, you can call from the other.
I'm not so good at programming because I'm a mechanical engineering. So
be positive. Say you are good. That's the first
step. I will be, but I know now I'm not active.
In artificial intelligence and machine learning is based on contrast. So when we prepare the training material, it's as if the learning is based on the contrast. So when I perceive something that I am good at, is because I know what I'm not good at. So it's always a contrast that we learn things, and that's how we train the machine. Okay, thank you very much. Yutian? Sorry,
Hello, Professor. Hello, everyone. Good evening. I'm a bachelor in electrical engineering, and I got a Java programming background during my undergraduate year. From electrical and computer engineering, graduate program in Ottawa, and this is my second year. I'm looking forward to get to know more about data analyzing with machine learning, and I prefer to use it to image processing.
Okay, we'll be focusing on text, but you can probably use the same algorithms for vision.
Yeah.
Wissam?
Yes. Hi.
Hi.
Can you hear me?
Yes, yes,
Okay.
Wissam, go ahead.
So I'm Wissam. I did my undergrad in Lebanon. It was in bioinformatics. And yeah, and this is my second semester here at the University of Ottawa. I'm doing biomedical engineering. I took a data mining course in my undergrad. We used R. I also know Python and Java. And I'm interested in the field. That's why I took this course.
You'll be popular to get part of the group. Welcome to the class. Thank you. Yuan Zhu.
Hello, Professor. My name is Yuan. My major is electrical and computer engineering. I'm doing a master's degree right now. I'm choosing this course because I see a lot of job postings talking about data science, but very little about this area. That's why I hope I could learn more from this course.
There should be a balance between what you like and the job posting. So I presume you also have some internal interest in the topic.
Yeah, I have some. Thank you.
Okay. Thank you. Jingyu Chen. The reason I say that is because, you know, we would be good at what we'd like to do. So, mature graduate students, you know.
Hi, Professor. Can you hear me?
Yes, go ahead.
Okay. Yeah, good afternoon, Professor and everyone. My name is Xingyu, and this is my second semester in the Digital Transformation and Innovation program. My background is that my previous bachelor degree was in finance, and I also worked in like a hedge fund service company before. Looking forward to learning about Python in the class and also have the opportunity to practice it. Thank you.
Thank you very much. Yutian.
Sorry, Professor. I think I did it before.
Okay. Zane.
Hi, Professor. Can you hear me?
Hi, Zane.
Yes. Hello, everybody. My name is Zainur Rahman. I did my undergraduate from University of Toronto in electrical and computer engineering. Currently, I'm working at Ciena. It's a telecom company. The reason I'm taking this course is because I'm interested in this field and want to learn more about it. And this is my third course at University of Ottawa.
Welcome to the course.
Thank you.
So I've reached the bottom of the participants list, but if I have missed anybody, you go ahead and introduce yourself, please. Okay. So let's, you see my presentation, I presume. So like I said, we look at the, you know, kind of a high-level process steps that is common for all of your assignments, and we look at some test cases. It's nice to always have a perspective of the philosophy around machine learning when we get to busy deeply into the, you know, using the algorithms and so forth. Always fruitful to look at the nature and see how we can identify some gaps. So being cognizant of what is consciousness, what is intelligence, and so forth is always useful. Although these are very complicated philosophical terms and hard to define, there are different school of thought and so forth, but it's always important to keep an eye on it. For example, you know, the difference of machine learning that we're going to be using throughout the course and the case of a robotics or self-driving cars is, or the difference between human is that the self-driving cars have the similarity with human, that constantly getting data. So when we do machine learning training and scoring, it's more of a batch mode. Whereas in self-driving cars, or in case of human, we constantly getting data through the senses. And also another important attribute of human is that we, you know, when I'm speaking right now, I'm kind of aware of myself. I also can put myself into your shoes, and which is, by the way, referred to theory of mind, that we can perceive the other's impressions of these sense data around us. So these are the attributes of human intelligence and consciousness that we may want to incorporate into the, you know, artificial intelligence. If you know what I mean by, you know, being aware, and so the definition of awareness is also sophisticated, but it's worthwhile to think about it and get inspired to add some features to the machine learning algorithms so that we make them more reliable. This is a high-level view of a data science. So it's a practitioner intention that we want to make out of the course. So it's on the one hand, we have the you know, mathematicians who design the algorithms and design the blueprints. But on the other side of the spectrum, we have, you know, usability of those algorithms. And as a data scientist, we kind of play the role of a liaison between those abstract blueprints and the applications. So because the business owners on the other side of the spectrum, they are not aware of what are the capabilities of those algorithms, and also do not have the language to communicate between the two. But so there is this need in the middle to kind of marry up the two groups together, and the practitioner role comes into play. That we know, for example, such and such algorithm exists, and also we you know, listen to the business owners, executives, what the business needs are, and then we say, oh, by the way, we can use such and such algorithm to rectify and produce a remedy for this business issue. So that's kind of what we want to have in mind, that you know, if you at some point become very interested in opening the hood and know what are the intricacies of you know, internals of an algorithm, it's fine, as long as you put that as a secondary objective, given the economies of time and efforts. You know, when we are given I use the cars analogy. If I'm given a Lamborghini, I need to learn how to drive it and enjoy it. That's one thing, but how the engine is designed is another thing, right? So I have to be cognizant of my interest in the depth of the my mission and what I'm intending to do. You see the blue arrows on the right side. You see the work of a data scientist very iterative because the problem formulation of the on the top left, problem solving, the formulation of the problem is also kind of a chicken and egg thing, that when you have the result, you can refine the problem formulation. That's why it's very iterative. And when you have some results, you change the problem formulation, and then you refine, you change the result. Like I said, the domain expertise is required, and the business analysis, and then communicating all of those to the business stakeholders are important, communication. But at the end of the day, what we do is creating a story. So that's why I was alluding to earlier that it's important that we hone on the skill of storytelling and be able to communicate the results in lay terms for the audience, for the general audience, so that they understand. On the left side, you see the combination of different skills that make a good data scientist. It's a combination of art and science or entrepreneurship. You need to know programming and computer science, and you have to kind of have an understanding of the probabilistic models and probability and math and so forth. Where does the art part comes into the scene? When you, for example, you do the visualizations, the communications, and the way you do feature engineering and think about how to formulate the training material. Those are all artistic aspects of the work of a data scientist. And in a general sense, when it comes to action, everybody is a combination of artist and scientist. For example, Leonardo da Vinci is a painter, but he's also a scientist. He knows very well the texture of the colors and the dimensions, and we all know about his scientific work. It's similar to anything else. When it comes to practice, it's always a combination of art and science. An example of interacting with our stakeholders, that sometimes when you work in the industry, there's a vibe that executives get a sense that it's very good to use machine learning and use deep learning, but it all depends on the formulation of the problem. Maybe it would be solvable by an easy tool or a rule-based engine or different variety of tools. So this liaison role is important to manage expectations and kind of guide indirectly. So at the same time being very political and avoid creating any resentment, and managing everything is critical to be a successful data scientist. Credibility is at risk. We always have to work really hard to create credibility, and it can get trashed overnight if you make a small mistake. So it's very important to be cognizant of these attributes of the work. So again, high level on the right, you see the steps involved in creating a machine learning project. We prepare the data. They say 80–90% of the work is preparation of the data, and then plug in the data to the machine learning algorithm, go through iterations, and keep refining and improving the result. and then at the end produce the story that we want to tell, or the artifact of a model that has an application in the production environment. These are on the left different roles that are mostly involved as part of the successful project. Data science work is not a one-man job. You have the stakeholders, the business owners, domain experts. They all have to be on board. On the other side, at the bottom left, you see the database folks, data governance, the definition of the data, and also, the productionizing of the end result artifacts. So you have to collaborate with the production folks to hand off the scoring program at the end, and also create monitoring systems so that you enable your business owners to look at the deficiencies and keep improving of the models at the production side. Any questions so far? So if I may take a few minutes to put you in the, I just want to avoid getting you guys bored. Sorry, I'm looking at the questions. Okay, Osama is asking whether the software engineering background is critical to this. So I would answer this way to that question. It's a very good question. As much as it's important to know programming and software engineering, recent years, all the big players want to democratize the machine learning, and also the paradigms in learning programming has changed. So, given the availability of the courses and the availability of the tutorials openly out there, it's made the learning process much more efficient. So I'd like to say that, be more positive and encouraging to say that, you can, but each one of you know yourselves better than anybody else. So you know whether this is something that you like and you want to pick it up, you're willing to pay the price. Of course, if you don't have any programming background, it's going to be challenging. So it is important we are going to be using programming, and it's kind of an advanced course. So we wouldn't even have time to do the justice for the material that we intend to touch on in this course, let alone, it takes a few courses of the programming to learn programming. So I'd like to be positive, but you know better than anybody else if you can catch up or not. In civil, okay. Tim is asking whether we have established scheduled tutorials. We don't have that, but I can refer you during the course. As part of the course, you get directions in finding the material and tutorials. And we also have a very capable TA that can answer your questions. But Tim, again, to all of you, one important thing is that the 21st century students is the skill, given the nature of technology side of the material, they are always subject to change. So if we had a tutorial session and we take you through some of the techniques that are available right now, they may become obsolete in a month or in a few months or in a year. So I would have felt better as a professor or instructor to teach my students how to fish as opposed to giving them the fish. So the skill that you need to learn as part of the course is to be able to find what you need as quickly as possible, as opposed to knowing the answer. Finding the answer is the skill that you need to hone on, because the technology is always subject to change. Libraries that we used a few years ago, there are so many different ones, they do much better job. So I have to keep abreast and up to date of what is going on, and I need to find what is out there the most efficient way possible. Okay. Any more questions? So let's take a quiz and get you doing some activities. So we know there are different tasks and subtasks within the machine learning activities. Out of these tasks, especially in they fall into the natural language processing, question answering systems or chatbots. We also have vision, and we also have translation. Translation is also another field off of the natural language processing or recommendation systems. So the question is, which one of these are the most important ML tasks? So let's see if I can do a poll. Sorry, it kicked me out. I have to log in while you're thinking. Sorry, this is giving me a hard time to use the polling system on the Zoom. So instead, can I let you raise your hand and express your ideas about this question? If anybody volunteer. Which one of these, in your view, is most important? If you were to choose one out of these 5, the famous satirical prime minister who was accused of something, and then the king let him choose only one food. He chose milk because it was the most nutritious, and let him choose only one clothing, and he chose leather. So if you were to choose one of these 5, which one would you choose? That's right. Smart. Yes, clustering and classification is because it's a building block in all of the other ones. Good. So just a side comment about the data science high-level objectives. Is actually very important notion that we need to be cognizant of, is that when we do the formulation of the problem, as a data scientist, we are expected to also know simulation and optimization, and these are kind of the legs of a triangle that always interrelate. In the course, we're going to be focusing on the prediction, but it doesn't mean that we have to forget about our other responsibilities on the simulation side and optimization. And also, the engines also have overlap. So if you learn the algorithms of prediction, they also use some optimization techniques within the engine. And also the simulation uses bootstrapping that may be used as part of the, dealing with the imbalanced data and so forth. So the techniques are definitely have some overlaps, but when we look at the problem, we have to be cognizant of these categories. I always, when I interact with my business owners, I consider the first thing I consider is that, is this question can be resolved or solved by a simulation? Do we have enough data? If we don't have the data, then the simulation is important, because then you can produce data using simulation. And simulation is used, you all know, because the reality is too expensive to try. So we kind of simulate the situation with the numbers, and then we make arguments based on those simulation results. Also, optimization is when I have to prescribe something as opposed to predict something. The question is what would be the best thing to do? What would be the best course of options when we have a variety of different options that is hard for human to stipulate? So we use optimization. Also, optimization has soft and hard. So probabilistic optimization models are referred to as soft optimization models, that things are fuzzy and probabilistic as opposed to deterministic variables. And common between all of these three is that you have an input, you have an output, and you have a target. And as a byproduct of the modeling exercise, we also create some key performance indicators to help with the business intelligence dashboard design and creating reports and what would be important to keep an eye on. For example, S&P 500 is an aggregate index that, instead of looking at hundreds and tens of different indices, you only look at one, and it would work as a proxy to get a sense of, okay, overall, this is how my 500 top industry stocks are performing. Because it's human psychology. There is a rule that is only perceive 7 things at the same time. So the intention of some business intelligence dashboard designs that they put tens of different indices on one page, and it would be very difficult to use those dashboards. As a byproduct of the analytics work as a data scientist, we also create some aggregate KPIs to help the dashboard design. Any questions? So the the first thing first, business formulation is extremely important. You know, the most costly aspect of software engineering is what? Do you know? Cost billions of dollars every year. Getting the requirements right is the most important piece. So you know, what is intended to achieve at the end, we talk about it first. What it is that we want to achieve. We have to clarify it in the beginning so that everything is clear. Otherwise, all activities are going to be wasted. So these are some of the examples. For example, if let's say we want to forecast the revenue, forecasting revenue. So that if my target is revenue and I want to do some trending, then my input to the model is also going to be, you know, historical revenue. So my target and the input are kind of same creatures. So that's why it's referred to as forecasting. But the prediction machine learning models, usually my target is different from my input. If I have the same creature as part of my input to predict something, that would be cheating in a machine learning model. I can't put revenue in and expect the machine to predict the revenue, right? It has to be a different variable. And in the context of marketing, I used to work for GE Capital, and there was a, you know, they were selling mortgages. I have a little bit of a background music. If anybody dislike it, let me know. So as part of the project was to, they call the call center, and this is not just in the banking, it could be in a retail or insurance, any organization who has a call center to make cold calls. There's an analytics work that contributes to that activity, is to what is referred, the lingo in the industry is generating leads. So as opposed to having, you know, blind calls, the analytics group provides some leads that are more prone to turn, to be, you know, buying your product. So that's called lead generation in marketing. And a lot of characteristics of the, you know, subjects are input as part of the training, and then it would score the high probable buyers so that the call center can call them as opposed to everybody. This would be a huge cost saving activity, if you know what I mean. Again, this is a prediction model. Transportation, you know, nowadays, when you buy, you know, through the retail Amazon, it comes through Amazon or FedEx or other postal services, they notify us when we expect it. So this is a time delivery prediction. Again, it's machine learning predicting the time in supply chain. So I guess that was the last one, logistic, and you know, also predicting time and cost. You know, optimizing time and cost in optimization in transportation becomes an optimization exercise. So it's extremely important right off the bat we formulate the business question in the proper language so that we can use the data science templates according to the requirements. Any questions? Please feel free to interact and jump in if anything is not clear.
Just one question about what you said about the finance, where you said you want to predict the revenue, and you said you can't have the same input as output. In this case, what would you put as input for, just for example, just so I can get a better idea?
Okay, so the point here is to formulate the business question right off the bat as correctly as possible and communicate it with your business owner. So there is two things here. You could predict revenue, or you could also forecast revenue. You could forecast a lot of different things. We could forecast volume. But what the turning point between the two is that in a prediction formulation, you cannot have the target variable as part of your input. For example, if I formulate the finance revenue as a prediction using machine learning and take revenue as my target so that the machine can predict it, then the input could be the cost of machine, the human resource indices. It could be the factory, different sections of the factory indices, the human resource, all sorts of things that contribute to revenue, but not revenue. If you decide to say, okay, I want to know what would be my revenue in 2 months based on my current revenue and my historical revenue, then you can use the revenue as part of the historical data, but this is a forecasting modeling. So you use regression, you're doing extrapolation, you're doing trending, okay? As part of the training, you are supposed to use the same variable. It's okay to do that, but just be cognizant to distinguish between the two is the point here. So that this is an example so that you get a sense of intricacies of business formulation and the importance of the business formulation. We have to practice this so that we would be very skilled in formulating the business issue in a proper language so that we can use the data science techniques properly. Did I answer your question?
Yes, you did. Thank you so much.
Okay. It's on the one side, you have all these fancy tools, but then you have to realize which tool in your toolbox you use to tackle the problem at hand. That's a skill in itself, is the point of this page. I want to talk about the notion of similarity, because if you wonder, okay, after all, what is this machine learning that everybody is talking about? It hinges on the concept of similarity, among other things. But one of the important notions is the notion of similarity. And the example I usually use is, if I asked you, what is a crow more similar to a duck or a goose? Then you think, okay, I have to break down, maybe I look at the color, I look at the eyes, I look at the beak, I look at the length of the wings. So these are all different characteristics. So as soon as you ask a similarity question from human, our tendency is to break things down and find the attributes and maybe, but we also have an overall intuition that is very subjective. So it's very complicated to understand what is going on in human brain. And science is very limited in that understanding. But nonetheless, the notion of similarity is the basis of all machine learning. So we train the machine using historical data so that when you ask it, okay, what about this item? The machine can say which group this new item belongs to based on the similarity that it found as part of the training. So that's why it is important. So how do we define similarity mathematically? The intuition, one example is the in the Euclidean space, when you have vectors of different dimensions, on the right side, it's a 2-dimension so that it's imaginable for human, but you can have n-dimension vectors. And the distance between the vectors would be the similarity. So if I have the closeness in the Euclidean space, I can use as the notion of similarity, so that I can model the similarity mathematically. So then the transformation of the data is that I have to transform the data to bring it into the vector space before I can plug it into the plug in the machine learning algorithm. And you will see as part of the process, you know, after we gather the data, we have a major step that is called transformation or representation of the data. There are different ways of representations, and that's one of the important leverages that we have in improving the prediction quality. So what is the difference between supervised and unsupervised? One of your, you know, your first assignment in 2 weeks is going to be supervised machine learning. So we have the next 2 sessions talking about classification. Classification is supervised machine learning. What is the difference between supervised and unsupervised? Anybody?
I can tell that.
Go ahead.
Supervised machine learning is when we have some labeled data and we know what we want exactly from the data. But unsupervised is some big data that they are unlabeled and we don't know exactly what is the pattern or what will come out of this data.
Okay, good. So I add to that, what the notion of supervised is, who is the supervisor?
Model.
The model.
No, who is logically, who would be supervising the machine?
Algorithm. The algorithm.
Human.
Programmer.
Human, yes. Human, not the programmer necessarily, the expert. So human labels the data. So I say this, let's say this is a sentiment analysis. I say this paragraph has a negative connotation. This other paragraph is happy, is positive. Who is doing that? Human, I am doing it. So I prepare the data that is labeled positive, negative. This is a binary flag that I'm creating as part of my training material when I want to do supervised machine learning. Human is supervising it, and we have labels. The problem with supervised machine learning is what? What happens when we have human involvement? Anybody?
Subjective, it becomes subjective.
Another, I'm looking for another answer.
Introduction of bias.
That's also correct. Another, I'm looking for another issue with preparing supervised training material.
There's presumption of the outcome, so I guess that is biased. Never mind.
That's true. Sorry?
More errors?
No.
Rational boundaries.
Masa, say it louder, please.
Rational boundaries.
I'm not sure what that means.
Overfusion.
Gianio?
Overfusion. I don't
know. Okay. Anybody else? That's not what I'm looking for. What is it when we involve when we require human beings as part of the preparation of the data? Let's say I want to do supervised learning and I don't have label. I need human to label the data. What happens?
we need every single data to label it, like every single features.
No, it's the answer I was looking for. Maybe I'm not good enough to give you the clues.
Is it human cost?
Exactly. It's expensive. So in the absence of label and the costly and laborious aspect of the supervised training material, we use unsupervised techniques. So unsupervised, which would be your second major assignment, apart 2 weeks apart, is clustering. And we do that when we don't have the labels. And it would be costly to, it's not the case that we always have the labels, it's a luxury of having labels available, right? So we have to figure out a way to, so you see how important unsupervised machine learning is, to be able to create, manufacture labels. And there are different, variety of other machine learning algorithms that would be outside the scope of the course, but nonetheless, I want you to be aware of it. Is, for example, is a semi-supervised machine learning in which we kind of provide some sort of a guidance as opposed to labor-intensive exercise. So we have a very small set of labeled data, and we use that as part of a bootstrapping to manufacture more labeled data. So there are different, so be open to other classes of machine learning algorithms. It's not just because I'm teaching you these two categories, don't think that there's only these two, okay? Another very important category is reinforcement learning, is based on feedback, dynamically learn, dynamically labeling, basically. Okay, so these are, so I want you to be aware of the similarity notion and also learn the supervised and unsupervised. So the takeaway of this course, at the end of the day, I want to see, so there are so many different things to learn, but we are going to discipline ourselves to follow my lead and only learn the things that we introduce very well, so that you'd be you have enough ammunition to learn other things later. So these are kind of in my view, the building blocks that are necessary. So I've had students that are really excited about learning other things and get distracted. There are so many things to be distracted about. That's fine. Take a note, allocate time later, but focus on the material that we introduce. Because like everything else, there is a reason behind my madness, okay? You got to trust me on that. All algorithms have pros and cons. Again, as a practitioner, without knowing the details under the hood, we need to know the pros and cons regardless. Some are good with large volume data, some are expensive to run, some work on some representation of the data than the others. So these are the things that we need to learn. So it's similar to driving that Lamborghini. You got to know when to change the gear, what are these gadgets good for, and when to use them. When to use the turbo, when you're low on gas, what to do, and all sorts of things. Adapt to the situation of the business formulation. So far, so good. What are the training, validation, and testing?
I can say that.
Okay, go ahead.
Training validation is the one that we train our algorithm with that, but the test is when we want to find out if our the prediction is well enough, so we test our outcome with that test data.
What is the difference between validation and testing? Okay, before you answer that, let me tell you a situation. Time and